All right, so this week we're going to take a look at two sections, 3.1 and 4.1. Okay, 3.1 is on what's called inverse trig. 4.1 is on right triangle trig. I bet some of you did that in geometry, like if you've done SOHCAHTOA. People remember that? Opposite over hypotenuse, adjacent over hypotenuse. We'll look at that a little bit later in the week. But we're going to combine it with inverse trig, which you probably didn't do in geometry. All right, so anytime we do something, okay, in math, there's usually a way to undo it. So for example, if you add to a number, you can undo it by subtracting. If you multiply a number by something, you can undo that by dividing. If you square something, you can square root it. In calculus, if you differentiate something, you can integrate something. They're reverse operations. Well, there's got to be a way to undo the kind of stuff we did last week. Like if I press on my calculator, okay, it doesn't matter if I do this in degrees or radians. I'm doing it in degrees. If I press sine 45, I get 0.707. Well, there's got to be a way to take this number 0.707, work backwards, and get 45 back. Okay? And you can. Okay? And the way you do it is with what's called inverse trig. Okay, so on the calculator, if I did inverse sine of 0.707, the more numbers I type in, the more accurate it'll be. But basically, you can see if I type that in, it gives me back the number I started with, 45, basically. It's not exact because I didn't type in all the numbers. All right. So that's the first thing. I just want you to kind of understand what inverse sine is. It's a way to go back. Okay? It's a way to go back to what you had before. Okay. When we write out inverse sine, we normally don't write, like I have on the left here, inverse sine. We use this symbol. It's a sine with a -1 up higher. That -1 is not an exponent. It's a little confusing because that is the spot where you would normally put an exponent, but it's not an exponent. Just think of it as the symbol for inverse sine. And then another way of writing it, kind of an older way, you don't see it as much as arc sine. So if you ever saw the word arc sine, it means exactly the same thing as sine with a -1. And you probably noticed it on the calculator. The calculator uses the -1, okay, when you do inverse trig. I'm going to talk more about how you use the calculator later on. Okay? And we also have symbols for inverse cosine and inverse tangent. Okay? Inverse cosine is cosine with a -1. Older books, if you look at them, it might say arc cosine. And the way you write the inverse tangent function is tangent with a -1. Again, an older way of writing it is arc tangent. I'm going to stick with pretty much using that notation. Okay, that's what I use. Any questions on the abbreviations? All right. So last week, let's just put up a problem that we had here. Roughly, it's the sine of 45. I just typed that in on the calculator, and I got 0.707. What is that? 45 degrees. What would that 45 degrees represent? Yeah, that's an angle. And then this. It's just a number, okay? If you know SOHCAHTOA specifically, it's the ratio of the opposite side divided by the hypotenuse. So it has no units. It doesn't represent anything. It's just a ratio of it's a fraction, opposite divided by hypotenuse. Okay, so it's just a number. Now when we do inverse trig, this is what I just typed into the calculator. The inverse sine of 0.707 is about 45 degrees. Notice what happens with the angle and the number. Okay, what happened with them here versus here? Where's the angle in the bottom one? Yeah, it's over where the number was, and then where's the number in the bottom one? It's in where the angle was. So it's like when you use inverse trig, they switch places. This is the number, and this is the angle. So what's important to understand is anytime you go on the calculator and you press second, inverse sine, inverse cosine, or inverse tangent, and you type something in, the answer that you get on the screen, that 15.5, that's an angle. Okay, so that's the big thing we use inverse trig for, is to figure out an angle if you don't know it.
Do you round to the nearest number?
Generally we'll round to 2 decimal places with a calculator. So this one I just kind of rounded it to the nearest whole number, but in general we'll go to 2 decimal places. Okay, so that's one thing that, again, that's important. Anytime you use inverse sine, inverse cosine, or inverse tangent, and then you hit enter, that answer that you get on the screen represents an angle. Okay? So it's just the reverse of what we did last week. I gave you guys the angle last week. You told me the number. Now I'm going to switch it. Okay? This week, I'm going to give you the number, and you're going to tell me the angle. Okay? So it's like just the opposite question. We'll practice some in a little bit. So when you press on your calculator, inverse sine, and you hit enter, your calculator has to make a decision. Okay? And you'll see why when you look at this chart in a little bit. But sometimes there's more than one answer. And the calculator has to say, well, I can only give one answer, so what am I going to do for an answer? Well, anytime you do inverse sine and you hit enter, the number that pops up on the screen is always going to be between negative 90 and positive 90. Always. Okay, here's a couple. I got 44. I got 15.5. We could do inverse sine of negative 0.87. I get negative 60. I'm never going to get a number that's not between negative 90 and 90. It'll always be between those two. And if you're working in radians, that you're going to get an answer between negative pi over 2 and positive pi over 2. You can do this in radians or degrees. Angles can be represented either way. It's like measuring something in feet versus measuring it in inches. You can do it either way. It's just a different way to measure it. Okay, inverse cosine, a little different. Okay, anytime you press the inverse cosine button on your calculator and hit enter, the number that comes up on the screen will always be between 0 and 180. The reason it has to do that is because we have to make a decision. Sometimes there's more than one answer. When that happens, this is the answer we always go with. The one that's between 0 and 180 when we're dealing with inverse cosine. And when we're dealing with inverse tangent, we're always going to go with the answer between negative 90 and 90. Yes, that was going to be my next question. If anybody noticed the difference between the first one and the third one. They're both negative 90 to 90. But with inverse tangent, you will never get an answer that equals 90. And if you want to see why, if you look at your sheet, find the column with the angles in it, go down to 90 degrees, and then go over till you get to tangent. What does your sheet say happens at tangent of 90? Undefined. Okay, I'll come right back to this. But if you're looking at that sheet, go to 90, go to tangent, undefined. Okay, same thing if you go to negative 90, which is the same as 270. Go to tangent, undefined, right there. Okay, any questions on that? So where do these numbers come from? Why negative 90 to 90? Why not negative 100 to positive 100? Why is it negative 90 to 90? We're not going to look at that for all of them, but I'm going to take a look at it just for the inverse sine function, just to kind of get an idea of where that negative 90 and positive 90 come from. I'm going to look at it as a picture. All right, let's fill out some of the values in this table and see what we get. So in the column in the left, I've listed some angles. And on the right, it's the sine of what I have on the left. So let's start with 30. Okay, sine of 30 is 0.5, or 1/2. I can pick anything I want. I picked these four for a reason. You'll see in a second. Sine of 65 is 0.906. And let's do one more. We'll do the sine of 90. You get 1. So now, let's look at it the other way. If I did the inverse sine of 1/2, what angle would I get? What would I get?
Oh, the inverse sine.
Yeah, inverse sine of 1/2.
30.
I would get 30. What if I did the inverse sine of 0.906?
You get 65.
I would get 65, or 64.99. Okay, I'd get something pretty close to 65. What if I did the inverse sine of 1? I would get 90. Okay, if I do the inverse sine of what's on the right, it'll take me back to what's on the left. If I take the sine of what's on the left, it takes me to what's on the right. Any questions about the three examples I just asked about? All right, so now let's see where the problem comes in. What's the sine of 150? It's 1/2 again. So now knowing that, if I said to you, what's the inverse sine of 1/2? How many choices do you have? How many angles could you go back to? 2. That's a problem. We can't have 2. Depending on what you want to pick as the correct answer, they could both be correct, but we have to agree on which one we're going to use. Are we going to use the 150 or are we going to use the 30? Yeah, we are going to use the 30. Okay? And I'll show you a picture at why that's the one we would use. All right, so I've got this picture. Okay, that's a graph of sine. Okay, it's not a line. Okay, it's got a wave pattern to it. Has anybody ever seen that graph before? Kind of graph? You might see it if you look at if you had a device you could measure electricity with, and you look at the picture of electricity. Okay. Has anyone ever done that? Electrical or electronics using an oscilloscope? No? Another thing you can do with an oscilloscope is if you have a microphone and you talk into it, it'll turn your voice into a picture that looks something like that, depending on how you talk. So this kind of wave pattern, we see it when we study sound and electricity and some other things. But the point is, that's the function sine. In order for sine to have an inverse, okay, in order for inverse sine to exist, it has to pass what's called the horizontal line test. Okay, what the horizontal line test means is if you put a horizontal line in that picture, it can only hit it one time. Now, where I've put the horizontal line, does it only hit my blue wave one time? You think, Gabe? No. And that's the problem. That's why we're getting more than one answer. In fact, there's not just 2 answers. for the 1/2. There's an infinite. I could name angles all day that I take the sine of, and I get 1/2 as an answer. Here's another one. Sine of 390 is also a half. Right? You can just keep naming them. So we got to agree on which one we're going to use. So what we're basically going to do is we're going to block off part of the picture. Okay, we're only going to look at a small section of it. Let's try looking at this section. So just focus on, let me see if I can put this line behind. Let's see, I don't know if I can do it. Try one more time. Yeah, good enough. So focus on what's between those two white boxes. Does the horizontal line hit the graph more than once still? How many times does it hit it? Between the boxes. Yeah, it still hits it twice. That's looking at 0 to 180. Let's try this. That's negative 90. That's positive 90. So just look at what's between the boxes now. If I put that horizontal line anywhere between the boxes, okay, and move it up and down, how many times is it hitting that blue curve now? How many times? Just once. Between negative 90 and 90, this line will only hit that curve one time. Is that the only place it would only hit it one time? No, I could find other areas where this happens. But this is the area that we agree on. And it's the area that the calculator uses. So anytime you deal with inverse sine, that's why the answer is always going to be between negative 90 and positive 90. Because if you do that, you will only get one answer. In other words, this line will only hit that graph one time. And we could do similar things with cosine and tangent. I could show you the graph and go through why. But it's the same kind of reasoning. So any questions on why we stick between negative 90 and 90? That picture is the easiest way to visualize it. And same thing for, I could do cosine, but I'm going to hold off on that. So what I'm writing right here is what I just showed you right here. I showed you this idea that things switch. We're kind of doing the opposite. Okay, this is what you did last week. I gave you an angle, and then I said, like let's say 30 degrees. Tell me the tangent of 30 degrees. That was the question on the test. So I gave you the angle, and you told me what the tangent or the sine or the cosine or the secant of it was. Well, this week, this is what you do. This week, I am giving you what the answer would have been on last week's test. I'm giving you that answer. And you're working backwards to tell me the angle. Okay, so last week I told you the angle. This week you're telling me the angle. So it's just the opposite. Okay, and there's a couple ways we can work backwards to get the angle. Okay, one way is to use that chart that I showed you, that you all have. This chart will not work for every single angle that's out there. If you look at that column of all the angles, what kind of angles are in the column? It's only angles that are multiples of certain numbers. Do you know?
30 and 45.
Yes. The only angles that are, if I go to the chart, in this chart, are angles that are multiples of 30 and 45. If you've got to do something other than a 30 or 45, well, that's where the calculator comes in. But we'll practice using this chart a little bit. Okay. Does everybody have what we're kind of the big idea for this week versus last week? Okay. and this is what I just said to you. If the inverse trig function is an answer that is a multiple of 30 or 45, then you're going to go ahead and use your table. But notice the way I worded that. I said, if you're trying to answer something, answer a question, and the answer is a multiple of 30 or 45. What's kind of weird about that? Then you use the table. So the only way you can use this table is if the answer is a multiple of 30 or 45. Well, the thing is, if I ask you a question, so here's the point, right? If I ask you a question, if the answer to that question is a multiple of 30 or 45, then go ahead and use this table to figure out the question. What's weird about
We
that?
do that, we don't give the answer.
Right, you don't have the answer. This is like saying you need to know the answer before you figure out the problem. If the answer is a multiple of 30 or 45, then use this table. But how do you know what the answer is going to be before you figure it out? So if you look at this table, the way you can figure it out is there's a pattern to the numbers in this table. If you look at it, all of these numbers have some things in common. Like, what kind of numbers do you see in this table? Just generalized, there's different kinds of numbers, but just some patterns you see. Yep, there's negatives and positives. What else? Yep.
Roots,
What kind of roots? Can you be more specific?
square roots,
Even more specific? Square root of 7?
2 and 3.
Yeah, square root of 2 and 3 comes up a lot. So if you have a question and it involves the square root of 2 or the square root of 3, chances are the answer is going to be in this table. Okay, so that's one thing you look for. Square roots of 2, square roots of 3. What else should you look for? Besides square roots of 2 and square roots of 3. Yep, Gabe?
Ones and zeros.
Yep, you're going to see a lot of ones. You see a lot of zeros. You're also going to see a lot of negative ones. So pretty much, if I ask you a question and the question contains a 1, a 0, a negative 1, a square root of 2, square root of 3, or a negative square root of 2, same idea, you're going to look for the answer in this table. Okay, so the way you know to use this table is look for arguments. The argument is the thing in the question. I'll show you in a second. What I just circled in red, that's the argument. It's the thing I'm taking the inverse sine of. Okay? In this case, it's the number 1. So look for arguments that are 1s, 1/2, root 3 over 2, root 2 over 2, root 3, anything like that you'll find in this table. Okay, so the first one says inverse sine of 1. Is 1 a number that pops up in this table? Yeah, then chances are the answer is going to be in this table, and it will be a multiple of 30 or 45. So we already know that, and we haven't even figured out the answer yet. That's how you do it. Okay, so to figure this out, what you do is go to your column for sine. So you go to your sine column, and then go down until you find a 1, and then read the angle that's across in that row. So what angle would have an inverse sine of, or what's the inverse sine of 1? 90. Go down this column, find the 1, go over to the angle, 90 degrees. Now, let's look. Is there a second answer? Anything in the row below it there? That's a 1? Nope. Let's go on the next column. Anything in that column that I just did in red? Is there any number there that was a 1? No. So in this case, there wasn't a second answer. But if there ever is a second answer, we know what we should be between. Okay, there's a range for inverse sine, inverse cosine, and inverse tangent. Okay, so when we start to get to problems that have a second answer, we're going to keep that in mind. All right, let's try this one. Inverse sine of -1. Okay, does everybody have what's on the left? Okay. So I can put the table, it's kind of small to see it, so you might be better off just looking at yours. Anyone think they can tell me the inverse sine of -1? Yep, go ahead.
-93.
Yeah, so if you went down this column, there's your -1. Go over, there's your angle. Now, let me make that a little bigger. You had a choice here. You could have said -90, or you could have said 270. Why did you pick -90?
Because that's in our range.
That's right, that's what we have to be between the two numbers. Okay, so she picked the correct answer, -90. All right, let's try inverse sine of 1/2. Okay, inverse sine of 1/2. Now, as you go down the sine column, how many rows does the number 1/2 appear in? Two. It does appear in 2 rows. Jackie, can you tell me the first row it appears in? Yep, it appears in the row with the 30, and where else? And it appears in the row with the 150. So we have 4 answers to pick from. 30, -330, 150, or -210. All of those answers are correct, but we have to agree on the one answer that we're going to write down. And what did we say we have to be between? -90 to 90. So, out of the 4 answers I just said, which one is the correct one we're going to use? 30. That's it. Okay, try those 2 on your own. Inverse sine of √2/2, and inverse sine of -√3/2. Okay, remember what you have to be between.
Is the bottom one negative?
The bottom one is -√3/2. Yep. Okay, so as I said, while you guys were looking up the answer here, another way to think of inverse sine is look at this argument. The argument, that's the thing you're taking the inverse sine of. And this question is basically saying, what angle could I take the sine of and get that as the answer? Okay? I want to know what angle I could fill in right here, take the sine of it, and get √2/2 as the answer. Okay? Anyone think they figured out what angle? Jack?
45.
Yeah, it's 45. All kinds of choices if you look at the table. 2/2 appears here, and it appears again here. Okay, there's a pattern to where these things are appearing. Okay, we're not going to look in depth at that pattern, but there's a lot of patterns in this table. Okay, so you're looking at either 45 or 315, 135 or -225. And Jackie said the correct one, okay, the 45. How about -√3/2? Okay, negative 60. Let me erase this. Let's check. So I see negative root 3 over 2, and you got to make sure you're in the right column. Yep, sine, using the right column. And I see negative 60. And that has to be the answer. You can look and you'll find it in another spot, the negative root 3 over 2. But the other answers won't be between negative 90 and 90. Okay, so once you find the correct answer, you're not going to find another one. That's it. Any questions on that? Now, when we're solving triangles, okay, we're going to get into that later in the week. Some answers might not make sense. For the last two problems we did, which answer would make more sense here if you were solving for an angle in a triangle, trying to figure out how big it was? The 45 or negative 60? Yeah? How come 45 makes a lot more sense than negative 60?
45 and 90, that is a triangle.
Okay, why not? Why can't you have a triangle with an angle of negative 60?
Have a negative angle.
No, triangles don't have negative angles. So some of the answers that we're seeing in this table, when we start to deal with problems involving triangles, they're going to get narrowed down a little bit even further. We're not going to use answers that have negatives. It just wouldn't make sense to have a negative angle in a triangle. Okay? But for now, that's fine, because we're not talking about triangles at all yet. All right, well, you know what? Let's do one together, and then I'll let you try a couple on your own. Inverse cosine of 0. So just make sure you're in the right column. Don't be in the sine column. This time you want to be in the cosine column. Okay, first question. How many rows do you see as 0 in the cosine column? 2. I see it right here. And I see it right here. Let's make that a little bigger. So out of the 4 choices, they're all different. Which one is correct? Now, how come not negative 90? Isn't that between what we have to be between? Negative 90 to 90? No, now we're in cosine. So cosine is 0 to 180. Negative 270, that's not between 0 and 180. Negative 90 and 270 are not. 90 is the only answer out of those 4 that's between 0 and 180. Any questions on that? All right, so try those two. Okay, we're not going to do as many with inverse cosine. Same idea as inverse sine. You're just looking them up. See if you can find the inverse cosine of negative 1/2 and the inverse cosine of negative root 2 over 2. All right, so let's look up inverse cosine of negative 1/2. Okay, how many rows in the table had a negative 1/2 in them for cosine? Do you know? 2. We get negative 1/2 there, and should be in quadrant 2, right there. So again, there's a pattern to where it's going to be negative. We don't look at it too much in this class, but there is a pattern. That's why in my head I knew it had to be in quadrant 2, so I started looking over here. If you don't know that, it's not a big deal. You just look through every number till you find the negative 1/2. It's not that many to look through. Okay, and now, which answer do we want? 120, negative 240, 240, or negative 120? Yeah, 120, because that's the answer between 0 and 180. Okay, and how about inverse cosine negative root 2 over 2? 135. Yep. Anyone else get 135? Yeah. Now, if they wanted it in radians, what would you say in radians? Yeah, it's right there, 3 pi over 4. So you can either convert it by, convert it yourself to radians, or you can look it up on the chart. Okay, 3 pi over 4. I didn't do as many in radians, but you should be familiar with both. Does anybody need me to go back and show you how to do radians on these other ones? Anybody remember what you multiply by if you have to convert degrees to radians? Multiply by this and divide by something else. Yep, if you multiply by pi and divide by 180, that'll convert to radians for you. Right, and we'll try to, we'll do them together for inverse tangent. Just as a reminder, can somebody remind me, what do I have to be between this time? I'm not 0 to 180 anymore. Negative 90 to 90. What's different about that versus sine? It won't equal, right? It'll be undefined at the negative 90 and positive 90. Okay, so what's the inverse tangent of square root 3? Well, Miles, do you think you got that one? Inverse tangent square root 3? Yeah, 60. Yep. Just look down that column on tangent till you find square root 3. Go over and get the answer. Any questions on that? Hmm? Yep. Yep. Inverse tangent. So make sure you're in the tangent column. Go down to square root 3.
Yep.
There's your answer. All right, and how about inverse tangent of negative square root 3 over 3? Yep. Yep, negative 30. That one's on the back. Okay, go down to tangent column. It's the last, actually it's the last one. Negative 30. Okay, so any questions on how to use this chart to look up the answers? Or once you find the answer, how you know which one to write down? Okay. So if you've got arguments that have root 2s, root 3s, 1/2s, 1s, 0s, or negatives of anything I just said, they'll be in the table. If you have an argument like 0.65, you can look for 0.65, but does 0.65 appear anywhere in this table? No. So if it's not in this table, use a calculator. Every calculator is a little bit different with how you type it in. Okay, the best way to type it in, if your calculator works this way, is you type it in exactly in the order you see it on paper. You've got to get to these blue functions. Anybody know how you get to the blue functions that you have to press? Yeah. In a lot of calculators, you have to press second and then sine. And that's how you do inverse sine. On this calculator, I don't know if anybody uses this one. To get to inverse sine, you have to press see, watch these 3 buttons right here. If I press inverse, they change to inverse. All right, so now I'm typing in the inverse sine of 0.65, close parenthesis, hit enter. If your calculator is in degrees, you should get 40.54 degrees. So earlier somebody asked me about the rounding. This is where we're going to round to 2 decimal places. if they wanted that answer in radians, there's two ways to do it. One, take the answer you just got and convert it to radians yourself. Or two, a lot easier, change the mode on your calculator to radians. You can try to. And then once it's in radians, type in the exact same problem again. 0.71 radians, roughly. Do I need to put RAD if it's in radians? No, we don't have to label it. Do I need the circle if it's in degrees? Yes. Any questions on that? Okay, try that one. Inverse cosine of negative 0.24. Okay, Riley, did you get an answer for that one? 103.89. Anybody else get 103.89? Yep. Did you do it in degrees, I'm guessing?
Yep.
Okay, so that's why I put my degree symbol. Okay, if you're getting all these wrong, it's probably something simple with the buttons on your calculator. Okay, make sure you either figure it out or come ask me and I'll try to help you, but every calculator is different. Okay, and how about, let's try this one. Inverse tangent of 34.3. You can do it in degrees, but just be careful you know how to do radians, because you'll probably see both on the test. All right. James, you get an answer for that one?
No, I didn't do it yet.
Can you try that one, just to tell me what you get?
Yeah. 88.33%.
88 point, anybody else get 88.33? Get that? What should be my label on it though? Degrees. 88.33 degrees. Okay. Questions on how to do inverse sine, inverse cosine, or inverse tangent? All right. What about those three? Secant, inverse cosecant, inverse cotangent. Is there a button on the calculator to do those three? Do you see any of those symbols anywhere on the calculator? No. So you don't have a button to do them. But we can still figure it out. Let's say got a problem like this. Say the secant was equal to 3/2. What other function is very similar to secant? We flip this one to get the other one. Yep. The cosine. So if the secant is 3/2, what would the cosine be? Yep. It would be 2/3. Okay. And usually when you write this, there's a variable or something right there. So these two equations mean the same thing. If the secant is 3/2, the cosine is 2/3. Okay, let's try another one. What if the cotangent was equal to 5/2? If the cotangent is 5/2, what else do you know? Gabe? The tangent is 2/5. So what's the point of taking this and turning it into that, or taking this and turning it into that? Well, what's on top, you don't have buttons for on the calculator. What's on the bottom, you do. Right. So earlier, I wrote down, if I can find it, right here. To figure out the sine of something and get an answer of root 2 over 2. That's how you do it. This is how you do that problem. And we did that together. So, how would I do this problem? What would I type into my calculator to figure out what x is? Well, we don't have an inverse secant button, so we only have inverse sine, inverse cosine, or inverse tangent. Yeah, it's going to be something with inverse cosine. And what would you type in? Inverse cosine of what? Two-thirds, yeah. This is how you answer the question that's in that box. You type in the inverse cosine of 2/3. How would you find x here?
Wait, so those will be the same answer.
Yes, these two things are exactly the same answer. Doing it the way below, you have a button on the calculator. Doing it the way above, you don't. That's why we rewrite it the way we did what's below. How do you think you'd type in the equation tangent x equals 2/5 to find x? No? Inverse tangent of 2/5. If you can type that in, that is the answer to the question mark in that problem. I'm not going to type those in because that's not the one that I'm going to do. But let's try this one. You might be like, well, wait a minute, you didn't give me a fraction this time. All the other problems had fractions. Well, if you want to make it a fraction, what could you do? Yeah, just put it over 1. Now it's a fraction. So if you compare this and that, the two things I just circled in red, what happened when you rewrote it a different way? What happened to the 3/2? It flipped. When you take this and rewrite it like that, it flipped. That's the only thing that happens. That number flips. Okay. So instead of using inverse secant, what function am I going to use that's similar to it? And we just did it up above. Because I don't have a button for inverse secant. I do have a button for inverse cosine. So I'm going to use inverse cosine. But I can't just type this number in the way I see it. What do I have to do with this number? I have to flip it. And that's how you type that question in, because you don't have an inverse secant button. Let's type it in and see what we get. Inverse cosine of 1 divided by 1.45. I'm in radians. I'm just going to leave it in radians. It's 0.81. Okay, here's another one. Inverse cosecant. Mercedes, do I have an inverse cosecant button on my calculator?
No.
No. But what function do I have on the calculator that's basically this one flipped? Sine. So I'm going to use inverse sine. But I can't type in 2.6. What am I going to type in inside the parentheses? Yeah, I'm going to flip it. 1 over 2.6. So it's inverse sine of 1 over 2.6. And in radians, you get 0.39. Okay, and the last one. Kristen, do I have inverse cotangent on my calculator? No. But what function do I have that's similar to it? Yeah, so I'm going to do inverse tangent. But I can't type in 0.35. Ariel, what am I going to type in instead of 0.35? Yeah, you have to flip it. So anytime you want to do an inverse trig function that you don't have, do the reciprocal one, but make sure you flip the argument. Okay, so inverse tangent of 1 divided by 0.35. It's about 1.23. Okay, so now you know how to do inverse trig if the answer is a multiple of 30 or 45. Use your table. If it's not, use your calculator. Okay. If you're having trouble with the calculator, make sure you come see me so we can figure out how to use yours. Okay, homework tonight, page 187. It's 13 to 17, 19, 20, 21 to 33, 22 to 31, and 33.